All right, away we go with assignment 6C. So we are learning about these antiderivatives, or AKA integrals. And again, when they ask for a complete solution, they in essence want you to get it all the way back down to when it's y is equal to. That's in essence what they're asking. So here they get the derivative. So antiderivative would get us back down to the y. And so x squared would produce a 2 and then a 5x. And because we don't have any conditions, it has to remain as equal to or plus c. X is going to go to the third, so that eliminates the 3. X is going to go to squared, which eliminates the 2. And then the 7 gets an x and plus c. All right, here is one of those problems where you notice how there's both x and y in the problem. All right, so this is a little bit more rough. So what we're going to do is we're going to get a separation of variables. To do that, what I do is I multiply this dx to this side, and then, but what I need to get all these y's over here. So in essence, I'm going to be dividing by y squared. So I'm dividing by y squared on this side. So rewriting this, it'd be a division of y squared. So this is y to the negative 2. It has that dy. And then I'm left with 3x, and I get a dx. All right, so when I have both x's and y's in the same equation, I have to separate these variables. Okay, so from here, I can go ahead and just kind of do the problem. So I integrate both sides. So y negative 1 produces a negative 1. X squared would be a 3 over 2. All right, now I have to have this plus c. So where I generically put it is just at the end. On one side only, I put this plus c. All right, now I'm in the business of solving for y. So I multiply by negative 1. So this is going to leave me with 1 over y, and this is going to be, I'm going to consolidate this. So this is negative 3x squared minus 2c all over 2. I'll just kind of write it like that. So what I did is I multiplied it by negative 1, and I also got a common denominator. So now the ultimate step is what is y is equal to. So I flip both sides. And so this would be negative 3x squared minus 2c on the bottom of 2. How I would probably write that is this is negative 2 of 3x squared plus 2c. All right, so again, here I have both x's and y's. So I group this up and I multiply over. And I take this dx and I multiply to that side. So this leaves me with a square root of y, so that's just straight up to the 1/2. It's no longer a denominator. And a y, because again, I multiplied it, and it's now a top number. So that's my dy. And then I multiply, so I have a square root x and an x, and that gets multiplied by this dx. All right, so that's exactly what we want. Now we integrate both sides. I kind of should have mentioned that when I integrate, these kind of, they don't go away, but they just kind of let you know what it's with respect to. All right, so y to the 3 over 2, 2/3, y squared, so that's a 1/2. X to the 3 over 2, so that's a 2/3. X squared, so this is a 1/2, and then this plus c. If it's easy enough, solve for y, go ahead and do it. And this is kind of where I leave the problem right here. Get back to me a little bit later, but I think it's fine to get a common denominator. So I see a 3 and a 2. So if I multiply everything by 6, okay, this ultimately would be 4y to the 3 over 2 minus 3y squared is equal to 4x to the 3 over 2 plus 3x squared. And then I don't think you have to have the number on the C. This is my question. Do I have to have a 6 on that C? Because how I always do problems is the minute that you get a C, if possible, solve for C at this point. Don't do a whole bunch of manipulations and then try to solve for C at a more opportune time. So like if you do manipulate the equation, which I don't think it's really a manipulation, I'm not sure if I have to have a 6 on that C. That's my question. I'm not sure. I don't think I do. I don't think I do. But I don't know. I don't know. I don't think I do. Because I think it would be the same as if I multiplied this by 6 right here. It wouldn't matter. And I would get a generic C. So I think I just answered my own question. No, you do not need the 6. It's totally legit. Anyways, I like the one with fractions. I don't like messing around when I don't have to mess around. All right, so I multiply the dv and I multiply the sine at the u to the other side. So this is going to yield sine 3u. It's with the du. And then I have the cosine 2v, and that's with the dv. All right, so all u's are on the left, all v's are on the right. Now that that's accomplished, I can go ahead and integrate or anti-differentiate both sides. So sine goes to negative cosine. This is going to multiply out a 3, so I don't want that to be there, so I have to 1/3 that. Cosine goes to straight up sine. This is going to multiply by 2, but I can't afford that. So it's equal to c. Again, if you want to multiply by 6, that's totally cool. So this would be negative 2 cosine 3u. And this would be 3 sine 2v. Yeah, and I like the one with the fractions. Because again, in essence, what I'm doing is I'm multiplying both sides by 6 at this point. Before the C was even invented. All right, here they want get this all the way down to y. So here we will actually have 2 different C's. They don't give me any conditions to eliminate them. So the first derivative is going to be a 1/3. Okay, plus the first C. And then the regular y now, again, this is going to go x to the 4th, so I divide, so that's going to be 5/12 x squared, so this is a 1/2. This gets an x, and then I get my second constant. Okay, now they give me some initial conditions. So again, when they give you these initial conditions, what you get to do is you get to solve for these C's when they pop up. So let's just understand what the problem is telling us first, because we can't handle this multiplication. So this is x squared plus 3x plus 2. All right, so y is equal to 1/3 x to the third plus 3 over 2x squared plus 2x plus c. They give me a y value of -3 over 2 when x is equal to -3. I'm definitely going to use a calculator at this point. So -3 is getting stored as x, and I'm just going to see what the math on that right is. So this is 1/3 x to the third. 1/3 x to the third plus 3 over 2x squared plus 2x. And so that is the number. So this is going to be -3 over 2 minus whatever that was. So this happens to be 0. The c happens to be 0. Luck would have it. And so what this says is this equation is actually 1/3 x to the third plus 3 over 2 x squared plus 2x plus 0. Okay, here we have a separation of variables. So I multiply the sine 2y across. So I multiply the side by sine 2y. I multiply the dx to the cosine side. So the cosine 3x gets its dx on that side. Okay, so we integrate both sides. So sine goes to negative cosine and a 2, so 1/2. Cosine goes to sine, and then the 3 comes out, so 1/3. And again, we get this generic plus c. All right, so again, soon as that c is established, soon as that c is created, go ahead, plug in your values, and see if you can get that thing to get out of there. See what it is. So here they give me a y of 1/3 pi. So this is going to be cosine of 2/3 pi. And x is equal to 1/2 pi. So this is 3 over 2 pi. All right, so let's take a look at our unit circle, help get some values from this. So one of the values is we're looking at 2/3 pi, which is right there. So 2/3 pi has values of -1/2, positive square root 3 over 2. And another value that we have is 3 over 2 pi, which is down below, which has a coordinate of 0, -1. All right, so -1/2. Cosine is at the 2/3. Cosine is the x, so that's -1/2. The next one is the sine. Oops, excuse me, this is plus c. Sine, cosine, sine, so this is -1. And kind of minimize this, get myself a little bit more working room here. All right, so this right-hand side is going to be 1/4, positive 1/4. and then we're going to, that's negative 1/3, so we're going to have to add 1/3. Yeah, 1/4 plus 1/3 is 7/12. So what this is go back to the statement in which we originally had the C, and that is going to be negative 1/2 cosine 2y is equal to 1/3 sine 3x plus 7/12. I don't think we need to solve it from there. I think that's the end of the game right there. We'd have to multiply by -2 and take an inverse cosine and then divide by 2. So it'd be pretty disgusting. -2 inverse cosine and then divide by 2. Okay, so let's actually understand what this is saying. Second derivative. Oh, nope. I'm going to separate variables right now. I'm going to separate variables. Nope, I'm not. I lied again. So this is -3x to the -4. Okay, here we go. So first derivative, or first antiderivative takes us to the first derivative. This is going to go -3, which is already there. Cool, plus c. Okay, so again, when we get the c, do your darndest to get rid of it if possible. So they give me a first derivative equal to -1. Let me change colors here to kind of. -1 is going to be equal to, when x is equal to 1. So this is going to be 1/3 plus c. So that's going to be 1 minus 1, so this is -2. So this equation is actually -3 minus 2. Okay, let's go one step further. So we anti-differentiate this. So y is equal to x -2. So that's a -1/2 minus 2x. It gets its c. All right, and then I go ahead and see that y is equal to 1/2 when x is equal to 1. So this right-hand side is -1/2 minus 2, and so I'm going to have to take 1/2 minus that. So that gets to a perfect 3. So that implies my solution is going to be y is equal to -1/2 x to the -2 minus 2x plus c, which happens to be 3. All right, velocity and position in terms of time. So right now, okay, so these are both at when time is 0. So v of 0 is equal to 2, and s of 0 is equal to 0. I'm going to kind of write it in a more professional way. So the acceleration at time t is 5 minus 2t. All right, so if I take an integral of this, an anti-differentiation, that turns into a velocity. So that's 5t minus t squared, and that gets a c. So this is when I put in one of those initial conditions. So I know that my velocity at time 0 is equal to 2. A lot of times they use zeros to kind of help you along with the math. And I see that c is equal to 2. So this actual velocity equation is 5t minus t squared plus 2. All right, now the position is the derivative of this. And so this is going to be 5 over 2t squared minus 1/3 t to the third plus 2t. And again, we get a c. And now I'm going to use its initial condition. So at time 0, this is all time 0. It's equal to 0. So again, 0, 0, 0, c is equal to 0. Get just a little bit more room to work. So that means the position equation plus 0. So I have the velocity equation and the position equation in terms of t. All right. Oh, they're going to get, I see what we do here. Okay. So when time is 0, position is equal to 1, and at time 2, position is equal to -3. And we're supposed to, again, get equations for velocity and position. Okay. So let's go ahead and go to work. So they start us off with acceleration. So antiderivative of this will turn this into velocity. And I'll call that C1. Okay, I don't have any velocity information, so I can't start guessing right now. All right, to the position. Okay, this is where we really kind of need to go to work right now. Let's go ahead and take the easiest one. And the easiest ones in work are when times are equal to 0. That's usually when you get the most information. All right, so let's start with that. So if I go with time is equal to 0. Okay, so anything multiplied by 0. So that leaves me isolated with a C2. So that says C2 is equal to 1. That's good news. And so what we can, in essence, do is we can update our position. Our updated position now is 1/12 t to the fourth plus 1/3 t to the third plus C1 t. I don't know what C1 is, but I know that C2 is equal to 1. Okay, that helped us out. Now I'm going to plug in that other condition, and this will spit out, this will get an answer to C1, whatever it happens to be. So position at time 2. is equal to -3. All right, so here's some math. Let's make this easy on ourselves and store 2 as our x. So this is going to be 1/12x to the 4th plus 1/3 x to the 3rd. 1/3 x to the 3rd. I'm going to leave the c1 alone. That's going to be +1. All right, so -3 minus that answer gets us to a -8. And so in essence, what we're chilling with is 2c1 is equal to -8. And thus c1 is equal to -4. Okay, so what the heck did we just accomplish? Well, let's go ahead with our position. Our position is 1/12 t to the 4th plus 1/3 t to the 3rd plus c1, which is -4, so that's going to be -4 c1 plus 1. Jeepers, I'm sorry. -4 t plus 1. That's our position. And then we also need to know the velocity equation. And so the velocity is going to be equal to 1/3 t to the 3rd plus t squared plus c1, which is -4. Okay, a ball is thrown vertically upward from the ground with initial velocity of 5 meters per second. So that gives me a couple information. So at time 0, again, this is what I'm kind of running off of. At time 0, the position is 0 because he threw it from the ground. So also initial, so when time is 0, the velocity was a positive 5 meters per second. So that's what that opening statement kind of said. Okay, so gravity, that's an acceleration, is -9.8 meters per second. How long was the ball going up? So when the ball goes up, it has velocity, 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 velocity. Okay, the velocity, excuse me, let me show that a little bit different. If I throw it straight up, okay, it's going to slow down, slow down, slow down, slow down. And then it's going to technically stop, and then it's going to speed up. So if I need to know information about this top position, that velocity is equal to 0. That velocity is equal to 0 at the maximum height of this ball. Okay, so when velocity turns into 0, you are now looking at the maximum height, the top of the flight. Okay, so how long is the ball going up? So how long does it take for velocity to get to 0? So the acceleration, let's turn this into velocity. Velocity is equal to -9.8 t plus c. Put in that initial condition, so when velocity, excuse me, time is equal to 0, the velocity is 5. So the velocity equation is -9.8 t plus 5. All right, and so as I was kind of describing, the question is how long does it take to get to the maximum height? And so how long does it take for velocity to get to 0? So what I'm going to do now is I'm going to take my velocity formula and see what happens when the velocity is equal to 0. So this will be -5 divided by -9.8. It's going to take 0.5102 seconds to get to the very tippy top. That's when the ball is going up. From there, the ball is going down. How high will the ball go? That's a position. So I need to work on the position. So I take the derivative of velocity. That creates a c, but again, I have a condition that helps me out when s is 0. So -4.90 squared plus 50 plus c is equal to 0. C is equal to 0. That makes my position equation. Plus 0. All right, that is my position. And so they want to know how high will the ball go. Well, I know how long the ball is going up. And so all I have to do is ask this formula now, well, what is that position at that time? So what is the position at 0.5102 seconds? And so that's -4.9 t squared plus 5t. All right, yeah. Sorry. Usually it's a more substantial number. And so this is 1.2755. And this measurement is in a position, so that is going to be meters. How long will it take for the ball to reach the ground? So that is asking, hey, where is this position equal to 0? Where is that position equal to 0? So it's obviously when time is equal to 0, that's obvious, but that's at the start of the flight. The second one will tell you when it's going to reach the ground. So you throw it at time 0, and then this will tell you when it hits the ground again, when its height, when its position is 0. So that's when it's going to hit the ground at 1.0204 seconds. At what speed will the ball hit the ground? So that's velocity. And so the velocity, 1.0204, actually speed is very technically the absolute value of velocity. So this is technically -5, so speed is going to be 5 meters per second. I don't think I took that into consideration on making the answer key, because I think I overlooked the word speed. The speed is velocity, but it's just always positive. Dropping a stone from the top of the Washington Monument. How long will it take the stone to reach the ground? All right, this is going to be kind of involved. So they start us off with gravity. Again, that's acceleration. All right, so the velocity of this thing. And so the velocity, again, it's dropped. So because it's dropped, so that means at time 0, the velocity is 0. So what that lets me know is at time 0, the velocity is 0. And so the velocity of this dropped thing is -32t. All right. Position. Right. It's at this, so the position at time 0 is 555. All right, so we have velocity and position equations. Rocking and rolling here. All right, but the question is, how long will it take the stone to reach the ground? So reach the ground means the position is equal to 0. That's when it's going to reach the ground. So let's take this position. And set that equal to 0. That will be when it reaches the ground. So that's -555 divided by -16 square root. So 5.8896 seconds. At what speed will it hit the ground? So again, if it takes that long, I want to know what is the velocity at 5.88 blah, blah, blah. So the velocity is -32t. So this is cooking at 188, 4675 or in feet per second. Moving. Okay, a woman in a hot air balloon drops her binoculars from a balloon 150 feet above the ground. Okay, let's stop there. So that means position at 0 is 150. She drops her binoculars, raising at a rate of 10 feet per second. So the velocity of these binoculars at time 0 is +10. How long will it take for the binoculars to reach the ground? All right, so let's start off with gravity. We're talking about feet. So gravity with feet is -32 feet per second. So that means velocity is equal to -32t plus c. Put in that initial condition of time is 0. and that's moving at positive 10 feet per second. Okay, that's our velocity, but we want to know position stuff. So again, take the integral. All right, and so there's our position. Put in that initial condition. So at time 0, we're at 150 feet above the ground. Okay, so the two important equations are that guy and that guy, maybe the acceleration, but those are the big three right there. How long will it take for the binoculars to reach the ground? So the binoculars reach the ground when the position is equal to 0. That's what it means to reach the ground. So what this means is I take my position, set that equal to 0. I'll do the quadratic equation. So negative b plus minus the square root of b squared minus 4ac all over 2a. Could probably make that a little bit easier on myself, but that's really the point. So this is negative 10 plus minus. This is going to be 10 squared minus 4 times negative 16 times 150. Divide by negative 32. All right, so from this, I'm going to be getting a plus answer and a minus answer from the plus minus portion of the question. Again, this is representative of time. This is answering time. So negative 10 plus the square root of 9700 divided by negative 32 is a negative number. That is not the answer. So let's get that minus answer. Negative 10 minus the square root of 9700 divided by negative 32. That's what you're looking for. Because it doesn't make sense to have the binoculars hit the ground before you drop them. Okay, so it takes this much time for the binoculars to reach the ground. Seconds. All right, what speed will they hit the ground? That is asking what is the velocity at that time. So the velocity at time 3.3903. So the velocity is negative 32 t plus 10. .486. Talking about feet in seconds. Hooray, we're done.